Have you ever wondered why the temperature is so erratic and hot nowadays? Why we so often see stories of polar ice caps melting and of the importance to reduce the amount of fossil fuels we produce? The reason for this is the issue of global warming, covered in sections 8.10 and 8.11 of our physics novel, presented by Sophie, Maris, and John. Two main factors, both out of our reach, that contribute to global warming are sunspots and the pattern of Earth's orbit. These black dots are sunspots, areas cooler than the rest of the sun by 1500 degrees Kelvin. Sunspots produce large magnetic fields that break the sun's photosphere and occur on an 11-year cycle. Solar flares result from these groups of sunspots in areas of intense magnetic activity. A mass of energy and radiation erupts from these solar flares and travels to Earth's atmosphere, which increases the amount of radiation Earth receives. The shape of Earth's orbit has fluctuated from elliptical to nearly circular over the past 100,000 years. When the orbit is most elliptical, there's 25 times more solar energy reaching the Earth in the summer than in the winter. With this, the angle of Earth's axis cycles from 22.1 to 24.5 degrees. As the angle increases, summers become warmer and winters become colder. In order to understand the physics behind global warming, we must first understand the greenhouse effect. Earth's atmosphere is vital in maintaining a temperature suitable for living organisms. When the sun emits radiation in the form of visible light, radiation either bounces off of the atmosphere back into space or penetrates the atmosphere. The radiation that penetrates the atmosphere then comes into contact with Earth's surface and is absorbed by the water, foliage, and man-made objects it reaches. Some of this absorbed radiation is re-emitted into Earth's atmosphere in the form of infrared radiation. It is because of this emission of infrared radiation that the temperature of Earth increases. However, the drastic increase of Earth's temperature in recent years is caused by the growing emission of greenhouse gases produced by fossil fuels. When coal is burned to generate electricity, which then powers our cars, cools our houses, and turns on light switches, fossil fuels are emitted, causing an abundance of greenhouse gases in Earth's atmosphere. Major greenhouse gases include carbon dioxide, methane, nitrous oxide, fluorinated gases, and of course H2O. When greenhouse gases are released into Earth's atmosphere, they absorb infrared radiation, allowing an even lesser amount of infrared radiation to escape Earth's atmosphere. To summarize, the more greenhouse gases are emitted from the production of fossil fuels, the more infrared radiation is absorbed by these gases and the hotter Earth becomes. To understand the exchange of radiation between the Sun and the Earth, a simple model, such as the SAND model, may be used. As demonstrated in the greenhouse effect, there is a constant exchange of energy from the Earth to the Sun. Let us say that for every 100 joules of energy the Sun radiates into the Earth, 10% radiates back into space. After 3 exchanges of energy, the total amount in the atmosphere would increase to 243 joules. This process continues until equilibrium is released, at which 100 joules of energy are radiated into the Earth and 100 joules are radiated out. Studies have shown that as the amount of carbon dioxide in our atmosphere increases, the temperature increases at a similar rate. A factor that has caused this increase is deforestation, for trees absorb carbon dioxide and produce oxygen. When companies bulldoze trees to build fossil fuel-emitting structures, the temperature and amount of CO2 on Earth surges. Before exploring what we can do to reduce global warming, let us see what other efforts are already underway. The IPCC, quote, assesses the scientific, technical, and socioeconomic information relevant for the understanding of the risk of human-induced climate change, unquote. Over the years, it has analyzed the effect of the production of fossil fuels and greenhouse gases on global warming. The Kyoto Protocol was a treaty that hoped to reduce the emission of greenhouse gases per country by creating carbon credits, units of CO2 production. By placing a price on these credits, it encouraged countries to reduce their fossil fuel production. It can be difficult to comprehend the extent to which we as students contribute to global warming. Not only do we have an iPad, which must be charged daily, But in Miss Rowley's room alone, there are over 208 outlets readily available, as well as a constant stream of air conditioning and overhead light. So the question is, how can we mitigate the effects of global warming? To explain, here's a short PSA from our good friend John Watari.
Look how cute this polar bear is. Global warming destroys the habitats of polar bears by melting the land that they walk on.
Together we can save the polar bears by adopting a greener, more energy-efficient lifestyle.
We can use hybrid vehicles to reduce CO2 emissions.
Wait, stop! Reduce, reuse, and recycle. Thank you, John. So, to conclude, what are some other ways that we can reduce the effects of global warming? Recycle. Limit the use of excessive lighting and air conditioning. Conserve water by utilizing energy-efficient faucets and shower heads. Make sure to turn off all electronic devices once you are finished with them. Utilize the trade winds. Open the windows every once in a while rather than blasting the air conditioning. Suggest the use of alternative energy sources such as solar panels and wind turbines. Though these terms may sound cliche, even the smallest effort can help save these cute little polar bears. Thank you.